Math button, go over to what? Probability, and select the NCR function. And now you got to type in what R is. R for our example here was 3. And we get 120. All right, so do we all have access to that function on our calculator? Know how to access the permutation versus combination function? All right, good on that? And this would be the manual way of working it out. If you wanted to immerse yourself in the factorial function, you could also crank out to 120. Another example, at one school, the student government consists of 7 women and 5 men. How many different committees can be chosen with 3 women and 2 men? All right. Now, so ladies and gentlemen, we're going to form a committee, and our committee is going to have 3 women on it and also 2 men. How many different committees of size 5 can we form, adhering to these requirements here? All right. Well, this is what we got going on here. We need to choose 3 women and 2 men. I have a question for you. To form this committee, do you think order matters? In which we choose 3 women and 2 men? Do you think order makes a difference here for the forming of this committee?
No.
It doesn't look like there's anything about order in here. I mean, it doesn't look like, we're trying to fill specific offices. Okay, so I just don't see anything that points to order here. So I'm going to assume that order does not matter. All right, so therefore, we need to choose 3 women among how many women? How many women do we have available in our pool to choose from? 3 from 7? Okay, so ladies and gentlemen, we got to choose from 7 women, 3 women, where order does not matter. So 7 in combination with 3. Okay, 7 in combination with 3. But we got the word and in here. We have the word and we got to choose 2 men. 2 men from how many men? 2 men from what? A pool of 5 men, correct? So and means multiplication. So 7 in combination with 3, will our ways of selecting our women, times 5 men in combination with the fact that we need 2 of them. Our ways of selecting the 2 men. So what we got to do is multiply these together here, is what we got to do. And we will have enumerated all the ways of forming a committee of size 5 from the 7 women and the 5 men. Okay, so let's get on our calculator and show ourselves how to dial this up. Okay, here we go. Now, to be safe, this is what I would recommend. I would recommend you enclose both of these inside parentheses just to be safe. Okay, just to be safe. Doesn't hurt. Let's do that. So I'm going to type in what? 7. Hit your math button. Wait a minute. I need a parenthesis. Open parenthesis. Now 7. Hit your math button. Go over to probability and grab the NCR function, the combination function. 7 in combination with 3. Now I got to hit my right arrow key to bring my cursor back up to level. Notice this. Now, okay, now close parenthesis, times, open parenthesis, 5 in combination with 2. So 5 math. All right, 5 math probability. And we go down and grab the what function? Again, we grab the NCR function, and we're going to type in 2 there. 5 in combination with 2. Hit your right arrow key to bring your cursor back up to level, and then you just hit your closed parenthesis, and ladies and gentlemen, hit enter, and boom, we discover that there's 350 ways, different ways of forming a committee of size 5, where we must have 3 women, then we must have 2 men on the committee. 350 different committees are possible. And again, this is assuming that order does not matter here. I mean, it doesn't matter if we select Sue first, then we select, you know, Sally, and maybe we select Bill, and then John, and then we select Sheila. It doesn't matter in what order. We have our 3 women and we have our 2 men to form our committee of size 5. Okay. So there's 350 different possible committees that can be formed here. Any questions with how we did this problem here? Notice, not only did we have to use our combination function, but in an overall sense, ladies and gentlemen, we used our what? Fundamental principle of counting. Because there's 7 in combination with 3 different ways of forming a committee of size 3 women. And there's 5 in combination with 2 different ways of forming a committee of size 2 men. That's why we multiplied these 2 different enumerations together. We're using the fundamental principle of counting along with our combinations. So we're using a combination of rules we've learned here so far. All right. And this is basically just making more explicit what I just said, okay, in writing here. So, all right. All right, example 6, designing a calendar. To raise money for a charity event, a sorority plans to sell a calendar featuring pictures and bios of some of the school's most popular athletes. They will need to choose 6 athletes from a pool of finalists that includes 9 women and 6 men. How many possible choices are there? Okay, if they want to feature at least 4 women. At least 4 women. Now, our pool consists of 9 women and 6 men. We need to choose what? 6 athletes, right? But we have to make sure that we have at least what? 4 women on the calendar here, correct? All right. So, what do we got going on here? Choose 6 athletes from a pool of finalists, including 9 women, 6 men. Let's see here. How many possible choices they want to feature at least 4 women? Could we choose 6 women, ladies and gentlemen?
Yes.
Would that be, I mean, is that okay for this calendar? If we choose all 6 women? That'd be 6 athletes. Could I just choose 3 women? Is that possible?
No, it says at least 4.
At least 4. We need to adhere to this. So we can't choose, we can't choose no women. We can't choose 1 woman. We can't choose 2 women or 3 women. We must choose at least 4. But my question is still lingering about the guys here. Could we leave all the guys out and just choose all 6 women? Does this say anything about that in here? Anything? What would be your thinking on that? Would that be proper for this calendar?
I think you need to choose some men too.
Maybe at least 1 man, do you think, or what? Maybe at least 1, huh? Or something?
At least 1.
All right, so if we go under that assumption, and again, you got to admit, this is not 100% clear on that issue. But if we go on that assumption that, yeah, okay, we have to choose at least 4 women, but we have to choose maybe at least one man. Okay. So what are our possibilities? Well, As far as the women and the men are concerned, do you agree the possibilities here is that I could select what? 4 women. But if I select 4 women, that satisfies at least 4 women requirement. But I then can only select 2 men because I can only select 6 athletes. That's it. Or if I select 5 women, which is obviously allowable, I could only then select 1 man because only 6 athletes are allowed. We just got done arguing that it doesn't seem like it would be proper to choose all 6 women and 0 men. It's like, what about the guy athletes, you know? So I guess we will assume that this is not possible. So if that's the case, ladies and gentlemen, then these are the only 2 possibilities that we can have going on for us here for this calendar based on all these requirements. Okay, so basically put, then do you agree that, and I'm going to type this out, I could choose, what did I say? I said I could choose 4 women and 2 men, or I could choose what? 5 women and 1 man. Okay. Everybody see that there? Now, how many ways can I choose 4 women? Let's entertain this first possibility. How many ways can I choose 4 women if order does not matter? Then we're going to assume the order does not matter. So do you agree? How many women do we have to choose from in our pool? Let's see here. We have 9 women. Do you agree? 9 women. All right. So there would be 9 in combination with 4 different ways of choosing 4 women from what? 9 women where order does not matter. And means multiply. So now we're going to use our fundamental principle of counting times. How many ways can I choose 2 men where order does not matter from 6 men? Oh, that would be 6 in combination with 2. Or, you know what or means, ladies and gentlemen? And means multiplication. And means, or means addition. We need to add. Plus, how many ways can I choose 5 women from 9 women if order does not matter? Well, that would be 9 in combination with 5. And means multiplication. And 1 man. How many ways can I choose 1 man from 6 men? Order does not matter. 6 in combination with 1. There you go. That's going to give us the total number of ways that we can choose 6 athletes if we must have at least 4 women chosen. This will give us the total number of ways. Now let's see if we can dial this all up on our calculator here. So let's go get our machine. And again, for safety reasons, I would enclose your combination inside parentheses. So open parentheses 9 in combination with 4 times 6 in combination with 2 plus, wait a minute. I said I was going to put parentheses around all these individually here. I should adhere to that. Sorry about that. I should be putting parentheses here. All right, here we go. Plus, open parenthesis, 9 in combination with 5. Times 6 in combination with 1. Notice your calculator is going to multiply before it adds in accordance with the order of operation convention in mathematics. because your calculator does obey the order of operations. Alrighty. All right, ladies and gentlemen, I think we're ready. Hit enter and boom, we get 2,646 different ways of choosing 6 athletes if we must choose at least 4 women from 9 women. There you go. There's 2,646 different ways of doing that. Everybody understand how I converted my ands to multiplication and my or to addition? Alrighty.
I did something wrong. I didn't get that.
Oh, maybe I did something wrong. Let me take a look here, make sure I typed it in correctly. Let's see, 94629561. Yeah, looks like I got everything. There are 6 men, right? Yeah, okay. Yeah, it looks like I typed in, double check how you typed it in, if you're able to do that, or maybe just start over and try it again. Did anybody get this? This 2646? Anybody? Anybody get this 2646? So we're kind of using the fundamental principle of counting amidst our addition rule. And of course, our combinations. So there's a lot going on with this problem here. All right. So that was a good one to illustrate things that could occur in the future with a more complicated enumeration. All right. Were you able to get to 2646 out there?
I got it the second time I put it in.
Okay. All right. Now, again, we're assuming with this whole thing is that we have to select at least 1 man, because if we didn't, we would have to account for 9 in combination with 6 times 6 in combination with 0. If we could, we would have to add that one on also. But I guess we're assuming that at least 1 male athlete should be there, I guess. All right. All right, let's get rid of this. Everybody got that there? Okay. And let's see if they got the same thing here. Oh, well, guess what, ladies and gentlemen? They are allowing for what? All 6 women and no men. Do you agree? To be on the calendar. I said corrected. But anyways, if you allow for that, you'd have to add another, another combination here. 9 in combination with 6 times 6 in combination with 0. So if we had all 6 women chosen, how many ways can you choose 6 women from 9 women? Of order doesn't matter. It'd be 9 in combination with 6. And we would have 0 men. Well, how many ways can you choose no men from 6 men? That's 6 in combination with 0. All right. Anyways, you'd have to add on the 84 onto the sum that I had, and you get 2,730. See that? So we got to be careful. I mean, it seems like in our minds, what's the point? I mean, maybe you should have 1 guy on the calendar. Do you agree? Well, not according to this. It's possible just to choose all 6 women as athletes and leave all the guys out. So, yeah, I don't know. I mean,
So how would you look at it when you put it in Alex? Would you
well, you got to be careful. I mean, how you read this here. No, hey, do we agree in all honesty, in all technicality, it doesn't say that there has to be at least what? 1 man. Do you agree? Does that say, is it saying it anywhere in here? It's not saying it, is there?
It's not.
All it's saying is you must have at least 4 women, which means you could have 4 women or 5 women or 6 women. Okay. You got them. Yep. So that's the way you need to read it. I do apologize for that, ladies and gentlemen. But you see how we did the problem, correct? You got to add this product to this product to this product here, and you'll get your 2730. All right. So yeah, got to be careful how you read some of these things here. Don't read into them too much is the mistake we made there. we read into it too much and tried to assume something that was not explicitly indicated in the word problem whatsoever. That's how we got into trouble. That's how I got into trouble. So be careful when you read these, all right? Just take them for literal, the literal way of the words you see, and that's it, all right? Don't read into it and put things together that are not even in there. Right? So just be careful. All right, let's see if we can go and see if we can go get our textbook here and get into 10.3 and do a couple of problems here. I don't think we've had a classwork yet, have we?
No.
We'll cook them up. We're gonna go here, right? Let's get into our. Let's get into our. Let's see. All right. So here we go. All right, so here we go. Wrong class. All right, so we're gonna go into section 10.3. Combinations, that's the name of our. Here. They have that problem in its entirety here, which is example 6 in your textbook, designing a calendar notice. You can study it in there when it's in its entirety. So it's also on a PowerPoint, same thing. So. All right, so let's see if we can dig into this right here. So what is the main difference between a permutation and combination? What is the main difference? Anybody?
Combination has no order.
With combinations, order does not matter. Permutations, order does matter. Okay, and how we select things. Right? That is the key difference. That's all you got to remember. All right, so that's great there. I just make sure that you can do a couple of these here. Number 17, do number 17 we'll open up a running tab on classwork 1. Make sure you can do 12 in combination with 3. Go ahead and do that. We'll call that classwork 1. However you do it. If you want to do it the long way, be my guest. You want to use the formula, be my guest. Okay, go ahead and do that. Tell me what you get.
Can you also just use the calculator on this?
Yes, yeah, by all means. However you want to do it. The door is wide open. So I just want you to figure out what 12 in combination with 2 is there. All right. So 12 in combination with 2. And again, I don't really care, how you crank it out. I just want you to get that value. So obviously the quickest way is just to, use your calculator and use the NCR function here. So we'll type in 12, go get the combination function, math, probability, NCR function, and then we'll type in 2. And boom, we get 66. So did anybody get 66?
Yes.
All right. Good on that one. Now, ladies and gentlemen, I want you to do number 19. Throw that into classwork number 1, number 19. Compute 10 in combination with 7 times 5 in combination with 4. Go ahead and make sure you can do that on your calculator. All right, so let's check it out and see if we got the correct answer here. Should be 600. Anybody get 600?
Yes.
Yes.
All right, let's move on down. More complicated calculation. I want you to try number 21. Make sure we can all do this on our calculator. 21. Now, here's a strong word of advice. Make sure you enclose your entire numerator inside parentheses and your entire denominator inside parentheses to be safe about things, okay? Go ahead and see if you can dial it up, number 21. Let's see if we can type this in on our calculator here. Okay. Okay, so here we go. We're gonna type this in. I'm gonna close my entire numerator inside parentheses here. So there's an open parenthesis for my numerator. I'm gonna say 12 in combination. Now you don't have to enclose each individual combination inside parentheses. I was doing that, just multiplying them
Are
together.
you doing number 22 or 21?
It should be number 21. Yeah, hold on, let me go back.
You got 12 instead of 10. Yeah.
That should be 10 in combination with 3. Okay, here we go. 10. Okay, 10 in combination with 3 times, whoops, I forgot to bring my cursor back up to level. Now times 6 in combination with 2. 6 in combination with 2. Closed parenthesis divided by, now the denominator, open parenthesis, 6 in combination with 3. Times 5 in combination with 3. 5 in combination with 3. Close parenthesis. There you go. You just type it in like that. That should work. And then we should get our answer, which is 9. Anybody get 9 out of that?
Yes.
Okay.
Yes.
And we can check our answer, and the answer is 9. Okay, so it looks good. All right, so that's as complicated as it's going to get with your combinations. All right. Now let's go down. Let me clear all this writing out of the way here. Okay, let's move on down now and do some problems here. Okay, let's see here. Okay, now for problem 29, I want you to find both the combination and then the permutation. Go ahead and find both of these here. Which one do you think would be less? Which one's going to be greater? What do you think?
The combination?
Combination is going to be less than permutation. Oh, it's always true. Okay, go ahead, find those two. Convince yourself on your calculator that the combination is less than your permutation. We'll just throw that into classwork 1. Okay, so ladies and gentlemen, what do we get for 12 in combination with 4? She got a 495 and the permutation is 11,880. Notice the difference in size of these numbers here. There's a lot more permutations of size 4 than there are combinations because again, order matters with permutation. With combinations, you're throwing out all the double counts. That's why you have much smaller number for combinations here. Okay. All right. Hopefully you're getting these things here, ladies and gentlemen, and you're able to use your calculator a little bit here. Okay. So, all right, let's move on down here now. All right. Try number 32 from a list of 20 dishes he knows how to cook. Maurice chooses different dishes for breakfast, lunch, and dinner. Wait a minute, what are we doing with this problem here? Find combinations and permutations. Decide whether the selection desired is a combination or permutation. Okay. What would be your guess? Let's do number 31 here. So this is not classwork, ladies and gentlemen. This is not classwork. We're going to kind of do this as a class here. 31. 10 fans at a concert are chosen to go backstage after the show. Do you think order matters or not? Would that warrant the use of a combination or permutation? What do you think?
A combination?
Yeah, I would be based on how I'm reading it. I don't want to read, don't read into it too much now. Careful on that. But it just says 10 fans at a concert chosen to go backstage after the show. I don't think the order really mattered. Let's see. Would order matter and how they're selected? No, I don't really think so. I'd be thinking combination. Let's see. Yeah, okay, combination. Number 32, from a list of 20 dishes he knows how to cook. Maurice chooses different dishes for breakfast, lunch, dinner, and dinner on his partner's birthday. From a list of 20 dishes he knows how to cook, Maurice chooses different dishes for breakfast, lunch, and dinner on his partner's birthday. Different dishes for breakfast, lunch, and dinner. Well, what do you think? Permutation or combination? Your guess here. Different dishes for breakfast, lunch, and dinner. Now, it's not saying how many dishes they select for breakfast, lunch, and dinner. I'm assuming one dish for each, I guess. So let me ask you this. Do you think order matters here? In other words, the dish you select for breakfast, could you also then turn around and select it for lunch? Do you think?
That's possible.
It's possible, but what word? I think there's a word lurking in here that gives us an idea that it's not possible for this word problem. What word is that? Do you see the word anywhere? There's a word in here that suggests that we would not want to do that.
Is it the and?
No, not the and. Maurice chooses what?
Different.
Different. Right there, ladies and gentlemen. Maurice chooses different dishes for breakfast, lunch, and dinner. Meaning that if we choose, let's say, dish A for breakfast, we cannot, based on how we're reading this, it doesn't look like we're able to, choose it for lunch and dinner again. Which, if that's the case, then I think order would matter. Do you agree? In other words, if you choose dish A for breakfast, dish B for lunch, and dish C for dinner, do you agree that'd be different than if you choose dish C for breakfast, dish A for lunch, and dish B for dinner? That'd be different, wouldn't it? I think it would be different, correct? Yeah, because I got the word different, Maurice chooses different dishes. I would be thinking it's probably leaning towards a permutation where order kind of matters. All right, number 33, what do you think? The state elects a governor and lieutenant governor from a pool of 8 candidates. Do you think order matters here?
No.
Well, is there a difference in the offices of governor versus lieutenant governor? If they were identical offices, then order probably would not matter. Do you agree? But I'm thinking, well, governor, which one do you think has more authority, governor or lieutenant governor? What would be your guess?
Governor.
Maybe the governor, which means that it seems like these offices are not equivalent to each other. If that's the case, then yeah, it seems like, you know, the order in which you allocate your choice would make a difference. You know, whether you put Sue in for governor and you know, and Rick in for lieutenant governor or vice versa. I think it would make a difference then. Okay, so I'm thinking order matters, permutation. Let's see if they said permutation. Yeah, permutation. Okay. Now, number 34, a state elects 2 senators from a pool of 12 candidates. You think order in which how they select these senators matters, ladies and gentlemen?
No.
Probably doesn't matter too much here. Bottom line is the state needs 2 senators. Whether they choose Senator A first and then Senator B second, it don't matter if they chose Senator B first and then Senator A second. They just have to have 2 senators. Doesn't seem like order really matters here. I'd be thinking combination there. How about number 35? Lupe chooses an 8-letter password from the letters of the alphabet. 8-letter password. Do you think the password A, B, C, D, E, F, G, H is the same or different than K, L, M, N, N, O, P, Q? Same or different? What do you think? Or if you switch the order, do you think the 8-letter password A, B, C, D, E, F, G, H is the same as B, A, C, D, E, F, G, H? Same or different? What do you think? Do you think order matters in how you arrange these letters for a password? Does it matter with a computer system, do you think? If you're trying to form an 8-letter password, does order matter normally?
Yeah.
Yeah, order usually matters, doesn't it? Makes a huge difference. I would be thinking order does matter. I'd be thinking permutation all the way here. Let's see. Okay, permutation. All right. Number 36. Of the 6 optional community service projects in a service learning course, Haley picks 3 of them. Do you see any indication based on this reading where it would suggest that order matters here in how you pick these 3 of 6 optional community service projects? Does it look like order matters here at all? Any indication whatsoever?
No.
I don't see it anywhere. I mean, I don't see, you know, where it also says, oh, well, Haley also has to present these 3 projects in a specific order. I don't see any of that. I would think order doesn't matter here. I'd be thinking combination here. Number 37, when looking for a new car, you read about 10 different models and choose 4 that you would like to test drive. This is actually arguable here both ways when you think about it. But on the surface of the words we're reading here, ladies and gentlemen, if we take these words literally, we don't read into them too much. Does it look like order matters here in how we test drive these 4 cars? What order we test these 4 cars?
No, I don't think so.
I mean, I'm not really seeing anything where, you know, it's alluding to anything about order here. All right. Now, in reality, some of us would probably argue, well, now, wait a minute. If you test drive, you know, maybe a Ferrari first before you test drive a dump truck, you might be more persuaded to buy the Ferrari and forget about test driving the dump truck. Do you agree? I mean, if you argue that way, then order seems like it might matter, correct? In your decision as to what you're going to buy. But based on just the words we're reading here, I don't see anything about order. I don't see anything. So be careful when you read these problems. Don't read into them too much. You can get into big trouble. Okay. Take them for literal value based on the words you just read. I don't see anything that indicates anything about any order here whatsoever. I would be thinking combination. Let's see. Yes, combination. All right. Hey, I didn't know I was in this book, but here I am. 38. Mark looks over the novels on his bookshelf and lists his 5 favorite ranked 1 through 5. Do you think order matters here if you're trying to rank novels as far as favoritism is concerned? You think order matters here?
I
Yes.
think so. Yeah.
Oh yeah, ranking order. Rank order. Order means order, right? There is a difference. Yeah, order all the way. This is a permutation all the way. The way you rank these novels does make a difference. Okay. 39. In planning a salad for a banquet, a chef chooses 1 of 2 types of greens, 1 of 3 types of croutons, and 2 of 5 types of vegetables. Do you think that order matters, and putting together this salad, the order in which you choose these ingredients? Do you think the order matters?
Yeah. I mean, no.
I don't think order matters. Whether you choose, let's say you choose parsley or you choose, what's another green? Parsley and the thyme, let's say. They're both greens, correct? They're both going to be found in the salad when all is said and done. I don't think order matters in how you choose any of these ingredients. They're all going into the salad anyways. Do you think the salad would taste different as far as the order in which you present these ingredients into the same salad? Do you think that'd make a difference in the taste? The order in which they went in? In other words, if I added the onions first before the croutons, or if I add the croutons in first before the onions, is that going to make a difference, you think? Now, I'm not a chef, for example. I'll be honest with you. Maybe it does make a difference, but I don't know. For me, the way I'm reading this face value, I don't think order really matters. It's the same salad. Whatever we choose is going into the same salad. I don't think the order really makes a difference here. I would be thinking combination. Let's see. Yep, combination. All right. One last one. Ollie schedules classes for next semester from 12 different course choices. Scheduling times that fit into that semester's work schedule. Scheduling times that fit into that semester's work schedule. Ollie schedules classes for next semester from 12 different course choices. Scheduling times that fit into the semester's work schedule. You think order would matter there and how you select your courses from 12 course choices?
I would, yeah.
Well, I don't know. This one's a little bit more vague. It's kind of like you could teeter either way on this one. I don't really care for it too much. Again, the way I'm thinking about it, but I could be wrong. I have been proven wrong in this session on another one. Let's say you start work at 4 p.m. and you have to work from 4 to let's say 4 to midnight somewhere. And you see, let's say you see 3 classes that will fit your schedule, not conflict with your job from 4 to midnight. Do you think it matters in what order you schedule those classes? Class A, Class B, and then Class C, or Class C, then Class B, then Class A, or Class C, then Class B, then Class A? If they all fit into your schedule? Do you think the order matters and how you schedule these classes, so long as they don't and so long as none of them conflict with your 4 to 12 job? You think order would matter in that case? Probably not in that case. Do you agree? Probably not in that case. Is anybody reading this differently or interpreting this differently than me? So if I had to lead one way or another, I would probably be leaning towards combination, because once I find classes that will work for my schedule, I don't think it matters in what order you schedule those classes. You're going to take them all. They all work for your schedule. I'd be thinking combination, but that's just me. Okay. All right, let's try number 43. This will be classwork number 2, 43. Go ahead and read that, think about it. See if you can answer the question here. Number 43. Let's take a look at this here. How many ways can a student pick 5 questions from an exam containing 9 questions? Well, we just got to pick 5 questions, so I don't think order matters here. So I would be thinking, since order does not matter, I would be thinking 9 in combination with what? 5. And how many does that give us here? Did anybody get the 9?
126.
126, you are correct. 126 different ways. Now, there's another part to this question here. It says, how many ways are there if everyone is required to answer the first and the last question? So, we have 9 questions, ladies and gentlemen. 1, 2, 3, 4, 5, 5, 6, 7, 8, 9. But we have to answer the first and last question. That's a requirement. Everybody does. Well, that leaves 7 questions left. Do you agree? 7 questions left, of which we have to choose how many. Remember, we had to choose how many questions total. 5 questions, correct? Well, we already answered 2 of the questions. So we already burned 2 of our 5 questions. We only got 3 questions left to answer of the 7 remaining. So therefore, it'd be 7 in combination with 3 ways of choosing the last 3 questions among 7 choices. And that would give you, I believe, what? 35 different ways of finishing this exam by answering 3 of the 7 remaining questions. Order does not matter. All right, did we all get that there? Just making sense here? All right. Okay, now I would like to go down and do problem number 48. We'll call this classwork. Just call it a classwork. Okay, just send it in with all your other ones. Number 48. How many ways can 3 cars and 4 trucks be selected from 8 cars and 11 trucks to be tested for a safety inspection? Go ahead and try to figure that out, okay? Notice it doesn't allude to anything about order here. So I'm thinking combination all the way. Try number 48. All right, let's take a look at this one here. It says, how many ways can 3 cars and 4 trucks be selected from 8 cars and 11 trucks? Notice you got the word and in here, ladies and gentlemen. And means multiplication. It means we're going to be using our fundamental principle of counting. So we got 8 cars to choose from, and we're going to choose 3 of them. Order does not matter. So we're going to have 8 in combination with 3. That's a way to choose 3 cars from 8 cars. Order does not matter. And means times. We got to choose 4 trucks from 11 trucks. Order does not matter. Times 11 in combination with 4. That's the way of choosing 4 trucks where order does not matter from 11 trucks. You got to dial this up on your calculator and you'll have your answer. Okay. And so what's that going to give us here? Hold on a second. So I'm going to bring that up on my calculator. So I got 8 in combination with 3. Whoops, I keep forgetting that. Times 11 in combination with 4. Yeah, you don't have to enclose these inside parentheses like I was doing earlier. I don't think that's necessary. There's nothing wrong in doing that, but I don't think it's needed. And that should give us our answer. Did anybody get 18,480 different ways of choosing 3 cars and 4 trucks from 8 cars and 11 trucks? We're getting that?
Yes.
Okay, good. All right, that's good. All right, that one's done. All right, ladies and gentlemen, I want to go down and have you do number 49 next. Just add that this to your classwork. It says, during the trials for a university pep band, there were 4 trumpet players, 12 drummers, and 7 saxophonists. How many ways can the jazz band be chosen so that there are 2 trumpet players, 5 drummers, and 3 saxophonists? And we will assume that it doesn't look like there's any indication of order anywhere in here. I'm thinking combinations. Go ahead and try number 49. All right, let's take a look at this here. Now, we want 2 trumpet players, and we're gonna choose 2 trumpet players from 4 trumpet players. Order doesn't matter, so that'll be 4 in combination with 2 ways of doing that. How many ways can we choose 5 drummers from 12 drummers if order does not matter? There's 12 in combination with 5 ways of doing that. Times, how many ways can I choose 3 saxophonists from 7 saxophonists? Order does not matter. It'd be 7 in combination with 3. You multiply all these together, these combinations, and you should get an answer of 166,320. Did anybody get that? Did anybody come up with that? 166,000?
I did.
That would be your answer. All right, one last problem, ladies and gentlemen. This is it. We'll call it quits today. Number 50, the last one. This will be your last homework. Number 50. Go ahead, try to do that problem in the time remaining. Okay. So if the bouncer can choose 4 people from the pool of people that he has to admit into the place, 2 have to be women and 2 have to be men. So how many ways can we choose 2 women from 5 women if order does not matter? 5 in combination with 2, and we need 2 men to be admitted, which is to say 7 in combination with 2 ways of choosing 2 men from 7 men. Order does not matter. 210 different ways in which the bouncer can admit 2 women and 2 men. Suppose, however, there must be at least 2 women that are admitted of the 4 people that are admitted. Well, that could mean 2 women admitted and 2 men, which means 210 different ways. Or we could admit 3 women and 1 man. 5 in combination with 3 is the number of ways of admitting 3 women from 5 women. Order does not matter. Times 7 in combination with 1 is the number of ways of choosing 1 man from 7 men. Where order does not matter, it'd be 70. All right. Okay. 70 different ways of choosing 3 women and 1 man. How many ways? But there's a possibility of choosing all 4 women to be admitted and no men. That would be 5 in combination with 4 times 7 in combination with 0, which is 5. So there's a total of 285 different ways. All right, of admitting 4 people from the line of people they have to choose from. If there must be at least 2 women. At least 2 women means 2 women or 3 women or 4 women. Okay, did anybody get any of those correct? Are we getting this, ladies and gentlemen? This making sense here? Today we talked about combinations, okay? We showed ourselves how to apply combinations to word problems, and also embedded within the combinations, we were using the fundamental principle of counting. That's what's going on here. Fundamental principle of counting, fundamental principle of counting, fundamental principle of counting, okay? All right, there you go. And so that wraps this up for today. All right, so I will remain on the line for a couple minutes. If you have any questions or concerns, please do address them. If not, have a great weekend, and hopefully I'll see you next week.
Yeah, I got a quick question.
Yeah, go ahead.
So, this is Maximus. So with the next class after this, does 115 go to 116? Is that usually what happens?
No, we don't have a 116.
Oh, there's not? Oh,
no.
okay.
No. This class will enable you to then springboard into the STEM courses, which would be let's see, after this you could probably take like intermediate algebra, okay, math
Okay.
20, and then go from there if you want to. Okay.
All right, sounds good. Appreciate it.
Okay, you're welcome.
Have a good weekend.
You too.